Hello learners, and welcome to my class. My name is Joe, and here we have been told to solve equation of 4 sine squared theta minus 4 cos theta, which is equals to 5. But now in solving of this equation, we have been told that the ranges should be within 0 and 360 degrees. Now, first of all, I want to bring out a method that we use in solving such mathematics. First of all, you know this sign, when you say sine squared theta is the same as saying 1 minus cos theta squared. We know that. When you just say sine squared theta is the same as saying 1 minus cos squared theta lana. We know that. And since now we know this, now we can begin to work on this math. But let me also remind you another math that we usually say, in the same formula we usually say, cos theta is the same as saying sine into brackets 90 degrees minus theta. When you have now these two, it's easy for you to work on this math. And so let's begin. So I'll say solution. First of all, I've told you where we have sine squared theta, I'll be able to replace with this because this is the same as this, so I'll have to replace this to this. So here I'll write 4 and then sine. Since here there is sine, I'll put a bracket to distinguish the 4 and 1. So I say 1 minus cos squared theta. You see that? Now I can close the bracket the same minus now the other side 4 cos theta is equals to 5. Have you seen that, learn? Have you understood until this position? Now, if you have understood until this position, I'll go to what you call expanding. Expanding and substituting. My cos theta learner. Which now, when I'm going to substitute my cos theta is the same, I've told you, is the same as saying sine here 90 degrees. That is minus theta. This is just what I've just written here, learner. So now let's go on and begin to work on this. Now we have our math here. So this is what I'm going to work using the new normal. So where we have cos theta, you'll see me like here substituting with this learner. So this is what I want to do. Remember, this is in the bracket, we have just substituted it. So the other one we want to substitute, as we have substituted for sine, now we want to substitute for the side of cos. Then let me substitute. So I'll say 4 into bracket 4, of which if I was to multiply, I would just write 4, but let me at the moment write cos minus cos squared theta. I close the bracket and say minus 4. Now this time round, I want to substitute this cos theta learner with this. So I'll write sine into bracket 90 degrees minus theta is the same as, is equals to 5 learner. So if you have seen what I've just done until to this position is just substituting of this. And then now from this position, I can begin to open the bracket on this side. Well, it will be 4 minus 4 cos squared theta. Then I'll say minus 4 sine 90 degrees minus theta is equals to 5. I've substituted the 4. Now, this is how my math looks like. Now, at this position, learner, I want to remind you one thing. We usually say using the trigonometric identity. It will be the same as saying sine 90 degrees minus theta is equals to cos theta, as I've just told you, learner, here. This I've just written, you can just put it the vice versa. Cos theta is equals to sine 90 minus theta, or you can begin by saying sine 90 degrees minus theta is equals to cos theta, learner. So I want you to see this one working as I've just shown you the first one working. Now we are here, step by step. So at this position, I'm going to write 4 minus 4 cos squared theta minus 4 cos theta is equals to 5. Have you seen that, learner? Because what have I done here? As I've just said earlier on, that at this position we are going to substitute in the side of where we have sine 90 degrees is the same as cos theta. So this thing is just the same here. But here, I have just told you in this formula, we can arrange it to be like this. So now it looks the same now. If now it looks the same, now I can rearrange it by finding a value. Because you know, when the values are looking the same, now you can substitute with a certain value to make a quadratic equation. So here I say rearranging terms. So at this position, I'll say 4, this one I'll begin here, 4 cos squared theta, learner. Have you seen that? Then I'll say plus, this other side is 4 cos theta. Then, since you see the way it is looking like, are we together? Because we are rearranging. The first thing I've just taken here, I've just said, first of all, I'm going to equate the cos's with a letter which you are going to see down here. But I've said 4 cos squared theta plus 4 cos squared plus the cos theta. If I bring this 5 here, it will be a negative. And since it will be a negative, I'll take the 4 and subtract with the negative 4. So it will be 4 minus 5, which will give me minus 1 is equals to what? To 0. Have you seen what I've done until this far? So from this far, now I'm going to make equation to look the same. I'm going to make the equation to look the same, whereby I will say 4, I'll say this will be, okay, let me first make the formula whereby I can say let x is equals to be cos theta. So now I'm going to substitute the equation from this. So where I have cos theta, I'm going to put x. So here I have 4x squared, since here there is no squared, plus 4x, which I've dealt with this, learner, and then here we have minus 1 is equals to 0, learner. Have you seen that? 4x squared plus 4x minus 1 is equals to 0. At this position, it has formed a quadratic equation. Since it has formed a quadratic equation, I'm just going to write it here, which is 4x squared plus 4x minus 1 is equals to 0. So at this position now, what I'm going to do, I'm going to use quadratic equation. I will use a formula which we say x is equals to minus b plus or positive into square root b squared, that is minus b squared minus 4ac, whereby now at this position, is it minus or it's plus? It usually used to be plus 4ac over 2a. So let me substitute this, learner. So this 4 is going to be my a, and this is going to be my b, and then this is going to be my c, learner. So let me substitute. Here we have b, my b is 4, and then this 4 is going to be negative, so I'm going to write minus 4 plus or minus into square root. My b, as I've told you, is 4, but this time round 4 is negatives, so it will be the same as saying 4, because my a and this is my b. My b, this time around my b is not negative but positive, 4, so that's going to be 4 squared. So I can just write times 2. Then I say plus, what is my this is my 4, my minus, it's always minus, learner. The formula is minus, not plus. Minus 4a. What's my a? My a is 4, so I'll write 4 here, and then I have my c, and what is my c? My c is -1. I'll write like that, Lana. So all over 2, my a is 4, and then I'll be able to close it. So let me work on this now. So I'll say -4. So remember, all this is equals to the value of x. All this is equals to the value of x. So -4, Lana, is the same as saying plus or negative. 4 times 4 is the same as 16. Then here I have -4 times 4, which is -16. -16 times 1, that is giving me +16. Then the other side, 2 times 4, that is 8. And then from this position, I'll say my x is equals to -4 plus or minus into the square root 16 plus 16, that is 32, all over 8, Lana. Have you seen that? So I can conclude by saying x therefore is equals to, this is -4 plus or minus the square root of 32 is 8. The square root of 32, that is square root of 32. If you punch in your calculator, okay, you can just use the third form. When you use the third form, it is the same as saying 2 in the third form over 8, Lana. And then from this position, I can conclude by saying my value of x is equals to -1 plus, this is going to give me 2 because I have 4 here, which will give me by 4 in the square root here. So this will be the same as saying 2 over 2. So finally I can come and say cos theta is the same as giving me -1 plus square root of 2 over 2. So now I want to recall this. I want you to recall that I told you that cos theta, there is somewhere I was telling you that cos theta is the same as saying what? This thing in sine 90 degrees over theta. We remember in this range when I was telling you that cos is the same as this thing, and now we have our cos here. So this x is the value of our cos here. So this is the same as our cos, and our cos this time round you have gotten is -1 over 2 divided by 2. So now we are being told that when the range, Lana, we are being told when the range is 0 to 360. So the first thing you're going to notice is that cos 1 -1 plus square root of 2 over 2, Lana, is the same as saying this is my diagram, Lana. And now I want us to check on the diagram together. This is going to be my positions, and it's going to come from the 0 degrees all the way to the 90 degrees. If you punch in your calculator, you will realize that it's the same as giving you 135 degrees. So if I take from 0 to 90, and from 90, it gives me about my 135 somewhere here. This is my 135 degrees. Then this is how it will form my stuff. It will mean that this is where it's going to reflect it, Lana. This is how it's going to reflect it. Which is the same as saying, if I was to split it until here, that would be my 180 degrees. So if this is going to give me my 180 degrees from this position to here, then this position here, Lana, would be my 315 degrees. So right as I told you, if we are going to say that this is going to be, no, this would not be my 380, but I would add 180 from this position. So my 180 will be going to be here, then plus 315. So that would be somewhere here, Lana, here, like here, because this will give me 180 the first move, the second move, that will give me that's 180 plus 180. So that will give me 360 degrees. So I'll have to move my first move, which will be the completion of 300. So it will be reaching somewhere here. That's my 180 plus, so let's say 180 plus 135. That would give us 512. That's my 325. So that would not go from here. That would go from here to 180. Then I have to add just a little bit. So my learner, it will be here correct. It will be at this position where it will be my 325. 325 as I just 335. 135. This is going to be my 315. So my 315 is going to be a learner like that, as I've just shown to you. So now here comes the question. If this is going to be my 105, this is going to be my 315. And so we have the first value which we have just found. When theta, well, say when theta is equals to 135 degrees is the same as n, or 315. Again, if you punch on your calculator again, you will realize the same as n cos. Our cos which we had defined, which is our cos, the theta, is equals to -1 minus 2. This time round, if we put it in negative form, what will it give us, learner? Because when you put in positive form, it must put in the negative form. If you punch well in your calculator, it will give you 225. 225, learner, degrees. But now, as you have just seen, as I've just tried to show to you, where are we coming from? We are coming from this position here. So the first one here is going to be 45 degrees. So we have, so in similar, we can say similarly, we have 45 degrees. Then the other one, it will shoot all the way to come and give us, this will be our 90, then our 135, because 90 plus 45, that's 135, as I've just said. So that will jump us next to 135. It will begin at 40, learner. Thank you for seeing that. That will be my 45, and then this will be my 90 in that case. And then from there, it will come and give us at 135. So here's where we'll have our 135 degrees, learner. And then from there, as I've just told you, when it is at 135, is the same as, we are also speaking of 315. But if you punch on the negative side, you will see we'll have the 225 degrees in the negative side. So that will be giving us at 225 degrees, learn. So we have our 225 degrees. Then we can conclude with the last one, we will say and 315 degrees. So learner, go and revise and keep revising, and you will see, as I've shown to you, when I've just told you that cos sine squared theta minus cos squared cos theta squared is equal to 5. First of all, you have to range on this. Your math must be in this range. Then from there, you'll be able to substitute and then make it to be the same. As you saw, mine first I made it to be cos and then the other sine. Then finally I came and made it, and then from there I went and finished on it. Thank you so much for your time. I will see you next time as you revise.